Hello everyone, welcome back. Today marks the start of Q4 Week 3, and today we're going to begin Unit 9, which is all about sequences in series. The title of this week's lesson is Arithmetic and Geometric Sequences. For this week, please make sure that you do the following things. Watch this video, take notes on this video, and ask me any questions in Teams. Number 2, complete the classwork assignment. It is only 10 questions this week, still worth 20 points though, and turn it in on Microsoft Teams. The reason that it is a bit shorter and a bit easier is because you have a longer Khan Academy homework assignment this week. It is 8 objectives, therefore 8 points in the gradebook. Please make sure you start on that right away. My lecture today will be focused on giving you examples that line up very closely with that homework so that you can hopefully make it through the assignment without any problems. Okay. Other announcements for you. The governor this week announced that virtual learning will be happening for the rest of the year. So I will not see you back at Ribault, sadly, but I've gotten more and more comfortable with this online learning, and hopefully you are too. Remember, any questions that you have, any assistance, help that you need, I'm here for you. I'm just here for you virtually through the computer, okay? So please let me know either through email, on Teams, if you have questions regarding grades, regarding understanding material, because I'm here to help. Let's get started. All right, so title of the unit, we're talking about it this week and next week, is sequences and series. So this week we're focusing on sequences, next week we're focusing on series. All right, so what are sequences? Sequences are basically just patterns of numbers. That's it. We'll talk about arithmetic sequences and geometric sequences this week. Arithmetic sequences increase or decrease by a constant difference, meaning basically they're just patterns involving addition and subtraction. Geometric sequences, on the other hand, they change by a constant ratio, which just means that they are a multiplication or a division pattern. 1, 2, 3, 4, 5, 6, that's arithmetic series because you're adding by 1 each time. 2, 4, 8, 16, 32, 64, that's a geometric sequence because you're multiplying by 2 each time. So we're going to talk about how to write an arithmetic series as well as how to write a geometric series, and then we're going to move on into examples for your Khan Academy. The 3 ways of writing an arithmetic series. First of all, you can write a list of numbers. This is the easiest way, the most elementary way of doing this. Let's say that I have a list of numbers 4, -1, -6, -11, ... meaning it goes on forever. That pattern continues. This is a sequence with starting value of 4, and the common difference is -5. If you subtract 5 from a number, you get the next number. 4 minus 5 is -1. -1 minus 5 is -6, and so on. It keeps decreasing by 5. If it was increasing by 5, your common difference would be a +5. Now, what we're going to focus on this week is notation for writing these arithmetic series in 2 ways. Explicit formulas and recursive formulas. Explicit formulas are written in this way right here. It says a of n, meaning the nth term in the sequence, is equal to a sub naught plus d times n minus 1. What do these things mean? Okay, first of all, a sub naught, or a sub 0, that's your first term. So you can see when we actually substitute in our values, our equation reads a sub n, the nth term, is equal to 4. 4 is your first value, so 4 is equal to a sub naught. D is your constant difference. All right, so our constant difference was -5, so we plug it in right here. And then n minus 1 stays the same. But for instance, if you are using this explicit formula and you are wondering what is the 5th term in this sequence, yes, you could just subtract 5 from -11, but you could also use that formula. You could plug in 5 right here. 5 minus 1 is 4, times -5 is -20, plus 4 is -16. So therefore, a of 5, the 5th term in the sequence, is equal to -16. Recursive formula is the other way of writing this. And the recursive formula actually consists of 2 equations. You have a starting condition and then you have another equation that expresses how you get to the next number. So for a recursive formula, you always start off with your starting condition, and you write that this way: a of 1 is equal to a sub naught, meaning that the first term is equal to whatever your first term is equal to. In our case, we would write a of 1 is equal to 4, because our first term is 4. The second formula in your recursive formula, the second equation, you write as a of n is equal to a of n minus 1 plus d. What this means in normal language is it means the nth term is equal to the previous term plus your constant difference. So for instance, -6 right here, the third term is equal to the second term minus 5. It makes sense, right? It's just weird notation. But we would write it for our series of numbers here at the top, 4, -1, -6, -11. We would write that equation as a of n is equal to a of n minus 1 minus 5. All you have to plug in is that d value for your constant difference. Going off the same type of idea, we are going to talk now about 3 ways of writing a geometric series. Geometric, those series, and I should have wrote sequence. Sometimes I mess the words up. Should have done it here too. Sorry about that. Correcting myself in real time. That's all right. All right, 3 ways of writing a geometric sequence. Talking about series next week. Let's say that you have a list of values. Again, a list is the first way of writing a geometric sequence, just listing the numbers one after the other. So our list that we're going to use for this example is written right here. It reads -1/3 as our first number, 1, -3, 9, -27. Our starting value is -1/3. Obviously, it's the first number. And now instead of a common difference, we have a common ratio, meaning if we divide a number by the number that precedes it, what do we get, right? If we take 1 divided by -1/3, or -3 divided by 1, or 9 divided by -3, if you take a number and divide it by the number that comes before it, what do you get? That's your common ratio. So in our example, divide a number by the number that precedes it, you get -3. Hence, our common ratio is -3. All right, so now the 2 ways besides a list that we can write our we can write our sequence is an explicit formula and a recursive formula again, except now it's a little bit different because you have multiplication going on instead of addition. Your explicit formula for geometric sequences can be written as a of n is equal to a sub naught times r to the n minus 1 power. For our example, a sub naught is the first term, so we plug in -1/3. R is your constant ratio instead of your constant difference, so we plug in -3 because we multiply by -3 each time to get that next number. And then we still keep it to the n minus 1 power. What this is saying is if you want to find the 6th term in the sequence, you would plug in 6 for n, do the math, and you would get your value, your 6th term in the sequence. And then a recursive formula, again, remember that recursive formulas actually consist of 2 equations. You have a starting condition, and then you have an equation that expresses how you get to the next term. So here, if we were writing a recursive formula for this geometric sequence, you would write a of 1, the first term, is equal to -1/3, obvious. And then the second equation says a of n is equal to a of n minus 1 times -3. That's saying that the nth term is equal to the previous term times -3. Test it out with these values and you can see, multiply the previous number by -3 and you get the next number. That's what the recursive formula is telling you. A question that I often get is which is better? The answer is, It really depends on the situation, okay? If you're looking for the 100th term in a arithmetic sequence, instead of writing out all the numbers to 100, right, plugging in n equals 100 to one of these formulas would probably be the easiest thing to do. So that's why we have formulas, is to streamline the process of finding those numbers in these sequences. We are ready for examples now. Today there will be 8 examples, and they will correspond to your 8 objectives that you have in Khan Academy this week. They're going to go a lot quicker than previous weeks. I'm not expecting this video to take as long as they usually do. So even though it's going to be shorter, it's going to be easier for sure. Please make sure that you're still taking notes and bringing your questions to me on Microsoft Teams. But this should hopefully be an easy 8 points of homework for you that you can get done really easily. All right. All right, so the example titles that I have written at the top of each page here, that's the actual title of the Khan Academy assignment that goes with the example, okay? So your first assignment on Khan Academy, your first objective, there are 4 questions, and it's called Extend Arithmetic Sequences. What I have here is an arithmetic sequence. Remember, that's a pattern of addition or subtraction. And the first number is -7, then we have -3, 1, and then a blank, all right? And basically, the objective asks you to fill in the blank. How do we actually do this? Well, we find the common difference, and then we just find the next number based off that common difference. How do we go from 7 to -3, or from -3 to 1? The answer is that we add 4. Right? -7 plus 4 is -3. -3 plus 4 is 1. So what is in the box? Well, whatever 1 plus 4 is equal to, which is 5. So if we were doing that objective on Khan Academy, 5 is your answer. You're probably like, whoa, that was it? Yep, that's it. We have hard objectives in Algebra 2, and we have easy ones. This is definitely an easier objective. Assignment number 2 is called Use Arithmetic Sequence Formulas. So instead of just looking at a list of numbers, you are going to see either, and that's why we have 2 parts to this. You will see the recursive formula, which is on the left here, or you will see the explicit formula, which is on the right here. The recursive has 2 equations, the explicit just has 1. We're going to start with the recursive. All right, so we have an arithmetic sequence. Our first term is 17. So I'm going to write that down below. Our first term is 17. Now the question is, what is the pattern, right? Well, we can see in our second line, it says the nth term is equal to the n minus 1 term, which means the previous term, plus 3. Just add 3 to the previous term to get your next term. So 17 is our first term. What comes next? Well, 17 plus 3 is 20. 20 plus 3 is 23. Then we have 26, 29, and so on. What is our fourth term? Well, 1, 2, 3, 4. 26 is the fourth term in this sequence. So that's what we would do if we were looking at a recursive formula. But you can also have explicit formulas, right? So here, this says, and I'm looking at the right side now, this says here, the nth term is equal to -13 minus 3 times n minus 1. If we want to find the third term in this sequence, it may not seem as obvious at first, but all you have to do is plug in n is equal to 3. Really straightforward, actually. So let's do that. We're going to plug in n equals 3 right here and right here. We will get the equation that reads a of 3, meaning the third term, is equal to negative 13 minus 3 times, plug it in, 3 minus 1. All right, so a of 3 is equal to negative 13 minus 3, parentheses first, times 2. 3 minus 1 is 2. A of 3 is equal to negative 13 minus 6. Multiply the negative 3 times 2. And then finally, a of 3 is equal to negative 19. And that would be your final answer. The third term is equal to negative 19. Example 3 is for the objective titled Recursive Formulas for Arithmetic Sequences. So what you're going to have in this objective is you will have a list of numbers. It will be an arithmetic sequence, meaning addition or subtraction, and you will have to write a recursive formula for those numbers. Please remember from the PowerPoint slide that all you have to do for a recursive formula, you are going to write 2 equations. Well, on Khan Academy, you're going to fill in blanks, but it's 2 equations that you need to fill in blanks for. The first equation is going to read a of 1 is equal to a sub naught. The second equation is going to read a of n is equal to a of n minus 1 plus d. For our problem here, what is a sub naught equal to? Well, a sub naught is equal to your first term, so this is equal to negative 3. Your first equation would read a of 1 is equal to negative 3. What is your d value? Well, your common difference is the difference between each of the numbers. If you did 24 minus 15, or 15 minus 6, or 6 minus negative 3, to get to the next number, you would have to add 9 each time, which means that d is positive 9. Your second equation would be a of n is equal to a of n minus 1 plus 9. And those are your 2 equations for the recursive formula. Example 4 is very similar. You will get a list of numbers, but instead of writing the recursive formula, you will need to write the explicit formula. The explicit formula is just one equation. Its general form from the PowerPoint is written as follows. A of n is equal to a sub naught plus d times n minus 1. A sub naught, again, is your first term. So a sub naught in this example is equal to 36. D is your common difference. For this example, d is equal to the difference between 2 adjacent values. So 49 minus 36, or 62 minus 49, in both cases we will get 13, positive 13. So that means that d is equal to 13. In your equation, your explicit formula for this arithmetic sequence is a of n is equal to 36 plus 13 times n minus 1. Now you can plug in whatever value of n to find the nth term in the sequence. If you wanted to find the 100th term in the sequence, all you would have to do is plug in n equals 100 and do the math. Look at that, y'all. We're already halfway done. Much easier week this week. Before I say that though, geometric sequences are a little bit tougher just because we have to do multiplication rather than addition, right? but it's not too bad. You do need to be comfortable with some of these examples with simplifying / reducing fractions, so make sure that you brush up on that knowledge, right? So example 5, the fifth objective in your homework is called extend geometric sequences. This is the same idea as example number 1, except now we have geometric rather than arithmetic sequences. So you can see that there is not a common difference here, right? 64 minus 16 is not the same as 16 minus 4. However, if we do division between, or finding the ratio between adjacent terms, that will be the same, okay? So what we are going to do now is we are actually going to calculate R. Oops. Which, remember from our PowerPoint, is called the common ratio. R is equal to a term divided by the term that precedes it. So for this problem, R is equal to 16 divided by 64. Or it's equal to 4 divided by 16. Or if you had a longer list, you could do this for any number divided by the previous number. That's the common ratio. So here, what does this reduce to? Well, 16 over 64 reduces to 1/4. What does 4 over 16 reduce to? It better reduce to the same thing because it should be constant. And yes, it does. It's equal to 1/4. So your common ratio for this problem is R equals 1/4. This is the value that you multiply by to get your next term. So find the next term. If that's the goal of our problem, all we have to do is take 4 and multiply that by 1/4. Let's do that right here. 4 times 1/4. What is 1/4 of 4? It's just 1, right? So this is our next term. Our final answer is 1. We are going to do the same thing now, except we are going to work with negative numbers / well, we worked with fractions before, but there's a separate objective in Khan Academy that's the same thing, except you are dealing with negatives and fractions, right? So here, what we are going to do is we are going to look at these fractions, determine the common ratio, and then find the next term. How do we do this? Well, the common ratio is equal to the second term divided by the first term, or the third term divided by the second term, right? So I'm going to do the second term divided by the first term. I'm going to do 9/4 divided by -3/2. All right, dividing fractions, got to be comfortable doing it. Keep, change, flip. 9/4 times -2/3, keep, change, flip, right? I can reduce this before I multiply, reduce it again before I multiply, and we get an R value of -3/2. This is the number that you multiply by to get your next number. So with that being said, all right, we've got to find the next term in this equation. In this sequence. We are going to take -27/8 and multiply it by our constant ratio. -27/8 multiplied by our constant ratio of -3/2. Negative times a negative is a positive. 3 times 27 is 81. 8 times 2 is 16. Make sure that you can't reduce the fraction, but in this case you can't. So our final answer is 81/16. That is our fourth term. All right, and now we're getting to the recursive and the explicit formulas again. All right, so we have two examples for this objective, really, on the left and the right, but they go pretty quickly. On the left, we have a recursive formula. It's two equations. The first equation reads a of 1 equals 15, meaning the first term is equal to 15. The second equation reads a of n is equal to a of n minus 1 times 2/3. That means that a term is equal to the previous term times 2/3. So what is the third term? Well, let's figure out a short list here. The first term, which we already expressed, is 15. How do we get the next term? Well, we multiplied it by this 2/3. So what is 15 times 2/3? Okay, so 15 times 2 is 30. 30 divided by 3 is 10. So my second term is 10. What is my third term? Well, now I take the 10 and I multiply by 2/3 again. All right, 10 times 2/3 is equal to 20 over 3. We can't simplify that, so that is my third term right here. And that is my final answer to this side of the example, this question. 20 over 3 is the third term in this sequence. Now to part 2 of this example. Instead of a recursive formula on the right, we have an explicit formula. It reads a of n is equal to there we go. A of n is equal to 2 times -4 to the n minus 1 power. What is the third term? All we got to do when we are asked that question for an equation like this is we need to plug in n equals 3 to this equation. We are going to plug that n equals 3 in here and here. So it will read now a of 3 is equal to 2 times -4 to the n minus 1 power, which means that we have to the 3 minus 1 power. N minus 1 now becomes 3 minus 1. Just erasing this so we have more room. All right, so simplify the group first, meaning the exponent 3 minus 1. So the third term is equal to 2 times -4 to the second power. Exponent comes next. What is -4 to the second power? -4 times -4 is 16. And 2 times 16 finishes our problem off with 32. And this would be the third term in our sequence. Only one more to go. Let's get to it. Recursive formulas for geometric series. Okay, so this problem we have some decimals. That's okay though, it works the same way. What I want you to do is to write a recursive formula for this geometric sequence. Again, this should read sequence, my bad. So with this problem, we should start off with the general form for recursive sequences. The general form states a of 1 is equal to a sub naught. And then our second equation in the general form is a of n is equal to a of n plus 1 times r, our common ratio. What is a sub naught equal to? That's just our first term, right? So a sub naught is equal to -0.6, easy enough. What is r equal to? Well, all we have to do is divide a term by the term that precedes it. So r is equal to 0.12 divided by -0.6. Please realize that we could also do -0.024 divided by positive 0.12. These two equations equal the same thing. When you plug it into a calculator, what you're going to get is 0.2. So that's your R value. If you have A naught, your first value, and you have R, your common ratio, you can write the equations just like that. Your first equation will read A of 1 is equal to negative 0.6. And your second equation is A of n equals A of n plus 1 times 0.2. All right, y'all, so that is it for this week. I know that this video was like half the length of my other ones, but again, this is just the easier topic than usual and doesn't require as much from me. But if you have any questions whatsoever, please make sure you're asking them on Teams. If you want to see additional examples of any of those 8 objectives that you'll be doing on your homework, please let me know. All right? And keep staying strong. We're going to keep doing this for the rest of the year. So get in the habit of, watching those lecture videos early on in the week and trying to take care of things before, Friday rolls around. Anyways, love you guys. Have a great week, and I'll talk with you later.